Hi, welcome everybody to my talk about Android. What I'm going to talk about today is actually more or less issues from the past. That's what I start with. I'm going a little bit into the Android security and code concept. And afterwards I'm going to talk about techniques for pen testers and reverse engineers. And in the end, I hope that's the most interesting part, where I dive into some experiences and general quality of apps, what I experienced at least. So my approach basically was I bought the HTC Desire last year. It was on Android 2.0. It's now updated to 2.20. And yeah, my approach was, of course, finding security-related issues, because I'm a pen tester, so obviously that's what I'm looking for. Well, let's start with the issues in the past. Basically, a lot of people are losing their phones these days, and it's getting closer to losing your laptop, because most people have like all their credentials and emails and everything on their mobile. So when I bought my HTC Desire for testing purposes, I bought it on eBay. And when I got the phone, the guy who sold it to me actually wiped it or factory reset it. But when you do that, there's actually a big pop-up which says, yeah, the SD card is not going to be wiped. And so, of course, he forgot to wipe the SD card afterwards. And I got all his private data, like pictures and everything on it. So first time I plugged it in, I already had private data of someone else. So that was quite an easy beginning. And the next thing, if you look at these phones, it is actually, you have these lock screens, right? And as a pen tester, you always want to get around these lock screens. So I was looking for one possibility for my phone. And I Googled around a little bit. And what I found was actually that on Android, you have to draw a pattern to unlock the phone. So it's not a pin. But to circumvent this, I simply power it off first. And as you will see when I power it on again, it's a rooted phone. You will see at the splash screen that it's rooted. But it would also work for non-rooted phones. So I just rooted mine, so you will see the splash screen. And what I'm doing right now is I'm hitting the home button very, very often and very fast during the startup process, all the time. And well, that's basically the hack, as we will see. So I'm still hitting the button, and yeah, you have to be quite fast. You have to have fast fingers. And we're in. We circumvented the lock screen. So yeah, it's actually quite a funny start if you just have to Google around a little bit. And the first measure of security is already circumvented on the first Google hit. So basically, there are some other techniques. So one is the technique I just showed. It works for not all brands, but for some of them on Android 2.2 and below. Some also allow to just press the back button during a call. So you call the phone, press the back button, and you also circumvented the lock screen. Some allow to just plug it into the car dock. So you take the phone, plug it in, and you have access to the phone. And what is also a feature is that when you actually forgot your lock pattern, you can type in your lock pattern 20 times incorrectly, and then it will ask for your Gmail address and password. And in the beginning, it was incorrectly implemented, so you specified the correct Gmail address, but as a password, you just typed in null, and it worked. So that was also a bug. It's now fixed. Well, and of course, a lot of people just don't have no lock screen activated. That's also, so if you find a phone, just first, most of them are like, you just can access them without any security measures at all. And another thing is, a lot of people have USB debug on, so that means you have like the debug feature is enabled, so you can just connect via ADB shell. ADB shell is basically like SSH over the USB cable. And another way to circumvent it is, of course, if you know the associated Google account, the Gmail address and password, because yeah, of course now it's fixed, but then you can just draw the pattern 20 times incorrectly, enter Gmail address and password, and you're in. Some milestone before Android 2.1 had also a bug in the bootloader, so you could just load this open recovery image and you have an ADB shell as well. And what also a lot of forensic tools do is like just acquire the physical memory directly. So what I get from a lot of people is like, is Android now open source or is it Google's or what's up? And Android is actually open source, so you can contribute, you can download the code, whatever. But of course, Google is the strong force behind it, and they will push development. And the Google market is actually not open source. So the Google market itself, where you get the apps from, is controlled by Google. And you can create your own market. But basically, if you buy an Android phone these days, there's always the Google market installed, so all the people will use that. So basically, it's still, the Android field is more or less owned by Google. Talking about the Google market, it's actually really a feel-free environment. What I mean is like, this is an error message the user gets for some apps. So it's like with swear words in it. And I found that in one app. And actually I think that wouldn't pass the App Store verification. So on Google Market, they're not checking the apps, but Apple does for its App Store. So I guess Apple wouldn't like that. And you can also see that if you go to the Android website, on the market website, and you search for ASDF, you find apps like test app, please ignore, like just random stuff on the Google market. So you can just put on malware there. Nobody will look at it. And a lot of users will download it actually. It's all, most people who just put on some random apps on the market, there are always like 500 users who will download it. It doesn't matter what it is. So talking about malware, Droid Dream, it's also called Rootcacher, was one of the malwares which made it into the Google market. Most of them are just spread over different markets in China, most of them. And the funny thing was that Droid Dream was detected by Google, and they wrote a remover tool for this malware. But actually the malware writers thought, yeah, well, if they do a remover tool, we do our own remover tool as well. So they wrote their own remover tool, which was actually another piece of malware. And they put it on the Chinese markets. So it's the BGServe is the remover tool. And the funny thing about that piece of malware is that part of it is released as open source. So you can download part of the code of the malware. And yeah, the guys are pretty funny. They put it on Google Code, so you can download the code from the Google Code page. Okay, if you want to bring malware to the mobile, as I said, the easiest thing is just to convince the user, or just put it on market. Somebody will download it. And another thing which John Oberheide found out is that a cross-site scripting on the Google Market website is also sufficient. So on Android, you basically have two options to install apps. First is you take your mobile, open the Market app, and say, yeah, please install that app. And it will install it. The other way is if you log into the website, market.android.com, and you install an app there. You log in with your Google account, which is associated with your mobile phone, and it will push it down over the Google push service. And it gets installed. So cross-site scripting is actually enough. So if you're finding cross-site scripting on the Google Market website, just send me an email or something. It would be pretty interesting. Another thing what malware also does is that if a user installs an app, he has to say, okay, this app can access my SD card and my geolocation and everything. But there are some exploits which just, if you already have an app on the mobile, this app can exploit vulnerability to install another app. So basically, there is an app which has no permissions at all, and it will exploit something to install another app which has all the permissions. And one thing was this Angry Birds extra level malware, which was done by John Oberheide. And there are some other vulnerabilities. For example, the Android browser is vulnerable to cookie stealing, or basically cross-site scripting on, you can do cross-site scripting from within an app for every website. It's now fixed. And there's actually also a new technique going to be released in November, also by Oberheide and Lani at Source Barcelona. So the Android browser, actually, I did some tests with different mobile OS. I used Apple and Windows Phone 7 and Android. And I was able to crash Internet Explorer on Windows Phone and also Safari on the iPhone. But I was never able to crash the Android browser. Well, it could be that Google just used the same fuzzer as I did, and that's why they already detected all the problems. So I think the Android browser is actually quite good normally. But what I don't like about it is that it puts bookmark pictures on your SD card. So SD card is actually a non-protected storage area. So everybody who finds your mobile can put out the SD card and plug it into his PC and access all the data on it. And what the Android browser does is, if you make a bookmark, it will store a small picture of how the website looks like and stores it on the SD card. So on my mobile, there's actually a small bookmark picture with my Facebook account and my SBB, what I was searching for. And well, if you do this, if you bookmark your mobile banking session, it will also put a picture of your mobile banking session on the SD card. It's more like a privacy issue, but still, it's not that nice. There are a lot of other issues with Android. They're getting better and better, but there were a lot in the past. Another issue is that the new version of the Facebook app, from version 1.6 on, it's able to read, write, and edit your SMS and MMS. And the worst part is that you cannot remove the Facebook app from the Android phone because it's in a special protected area of the storage. There were some other issues with plain authentication tokens. So like session IDs were sent over HTTP. So if somebody was sniffing, he could use these authentication tokens to access, I think it was Picasa. And sometimes the SMS received was just simply incorrect. So you were writing an SMS to your girlfriend, but in the end, your boss got the SMS. So it was quite strange. Another issue was just uncovered some weeks ago, the HTC logger, which means that is a service that is running on HTC, and you can query it, for example, for the geolocation, even when your app doesn't have the permission to access the geolocation. Of course, there's also some app reversing going on. I'm not the first one doing this, and it's getting more and more. And of course, there are a lot of other issues. So one day I found this small commit on XKCD, and it says basically the nuclear chain of command in America. It's like the president is on top, like is in charge, but actually he only has a red button. And if the engineer who installed the red button didn't install it correctly, the president can press it as long as he wants, and it will do nothing. So, like, the engineer is actually the one who is in charge, right? And this is somehow similar to the Android situation, because here we have Google on top, and Google is fixing all these security vulnerabilities and updating their software. But actually, on the other side, you have manufacturers and providers that don't provide you with updates. So we're now on Android 2.35, and actually my mobile is up to date, as we will see, and it's still on 222. No, actually even 220. So my situation right now is I bought the phone last year. I'm still on Android 2.0, and my phone tells me, yeah, you're up to date, you're fine, everything is good. And well, basically I'm vulnerable to the screen lock circumvention we saw, to the Droid malware, these browser vulnerabilities, cookie stealing, cross-site scripting, apps can install other apps. So basically, this is really scary, especially if you not only have testing phone, but your private phone is the same. So, okay, let's talk about the security and code concept of Android. When you write code for Android, normally you write it in Java and HTML and JavaScript. You use the Android SDK. It's the most obvious approach, and I would say like 95% of all apps on the market just use this approach. And of course, because it's Java and HTML JavaScript is already plain, you can decompile, disassemble, and reassemble the stuff very easily. And well, another option would be to write apps in ARM native code, but actually nobody does it. And if you find an app that does it, you can just do normal ARM assembler reverse engineering. So that gets a normal reverse engineering task as usual. You can also use some frameworks generators. I only know two of them, appmaker.com and PhoneGap. I think there are others. I had some slides about these two, but it was a little bit kiddie style, so I skipped them. Well, okay, let's dive into some techniques for pen testers and reverse engineers. So if you want to analyze Android apps, you have to get these APK files. So APK files are basically just Android apps. So one APK file is one Android app. And my approach was actually, I want to look into a lot of Android apps, not just one or two. So what I first did was I opened the Market app on my mobile. I clicked the app and said install, and afterwards I SSH'd into the mobile phone and just secure copied over the APK file. That works if you just want to download one or two apps, but actually it's slow and there's not enough space on the mobile, so every one of these apps gets installed on your mobile. So what I did was actually I tried to circumvent it so that not all these apps get installed on my mobile. So I connected my mobile phone to the laptop with over Wi-Fi. So I made a new Wi-Fi access point on my laptop. I used IP tables to redirect the traffic on port 80 to a local burp instance. Burp is actually just a HTTP proxy. Nothing too fancy, just an HTTP proxy. And yeah, I had to use IP tables because I could not specify a proxy in Android because Android has no proxy options. And I used burp extended, that's the scripting engine of this proxy, to save the responses with the APK files to my laptop. So they're not stored on my mobile, but on the laptop. And in the end, my laptop saved the APK file, the Android app, but sent my mobile a 404 not found. So it told my mobile, yeah, there's no such app. And my mobile said, okay, well, if there's no such app, then that's fine. But actually, the APK file was stored on my laptop. So, right, like this, I could just click an app on the Market, and it sends a request to Google over the Wi-Fi of my laptop. And when the app comes back, it gets stored, and my mobile doesn't notice anything. It just says, okay, the app is not coming. Now the problem is I don't want to like click every app on my mobile, right? So I had to find out a way to say, Google, please install all the apps that are on Android, on the Android Market. And so I found out that you just have to send one HTTP request to the Google Market website, and you just have to change the app name inside that request, and it will install that app. So now I had the problem. Now I know that I just have to send this request, but I have to find out all these app names, right? So the next step was to use a tool called W3AF. Actually, it doesn't matter. That's actually a web application scanner, but I just used it because I know that crawler. So I used that spider crawler and wrote a regex plugin, which just writes out all the app names from the Google Market website. So I told the crawler to go to the Google Market website, search for terms A to ZZ, and write out all the app names that are displayed. There were actually no restrictions at all, so you can just search, do as many search on the Google Market website as you want. And well, in the end, I wrote a script that sent this HTTPS request, takes the app names from the file and sends it to Google. So maybe that was a little bit fast. So this is like the entire environment. First of all, we have the crawler who looks for all the app names. And basically, we just have the a line-separated file which has all the app names in it. Then a small Python script takes these app names and sends requests to Google. Please install that app. Google will say, OK, I'll push down the app over the Google push service. And my output tables will say, oh, that's traffic on port 80. Redirect it to Burp. Burp will say, oh, I have a scripting engine who wants to know what I'm doing. So it will redirect it to Burp extender. And the Burp extender will save the file. So we have the APK file and send the mobile over the Wi-Fi and HTTP 404 not found. So basically, there are about 300,000 apps in the market. I crawled about 10,000 app names, and I successfully downloaded about 3,500, about 50 gigabytes. It took me about 3 days, but just left it running. So now we have these APK files, right? This is an Android app. What do we do with it? So we can decompile and disassemble it. If we want to disassemble it, well, actually, APK is nothing else than a zip file. So you can basically just unzip it, but then you have all this main.xml. It's not really an XML, but it's a binary format, binary XML, so you would have to convert it first. And also the classes.txt, that's where actually the code, the Java code is stored. And it's just one file, everything in one file. So it's not really handy to do anything with it. You cannot read the XML files and so on. So what you use is actually APK tool, which is much better because you get real XML files. For example, in Android manifest.xml, you can just look up which permissions the app is using. And what it produces as well is that classes.txt is converted to small code. So we'll see in a minute what small code actually is. Or, yeah. So we have basically two approaches if you want to decompile and disassemble. Disassembling and decompiling. So disassembling is done with small code. So small is similar to Jasmine syntax. Jasmine, I hope somebody knows it. It's Java assembler code. It's like assembler code for Java. And small is very similar to it. You use the APK, I use the APK tool actually just because it produces correct small code. So you can reuse it, you can recompile it, and it will work. I haven't used dexdump or ddexer, which basically do the same, but APK tool was enough reliable. The other approach would be decompiled to Java. Small code is pretty easy to read, as we will see later, but Java is, of course, even better or nicer to read. You use text to jar and just a standard Java decompiler. The problem is actually that it produces sometimes incorrect Java code. So if you have incorrect Java code, you cannot take this code and recompile it again to an Android app. So the disassembling how-to is actually just one command. You say java -jar apk tool.jar. D is for decompile or disassemble, sorry. App.apk is the APK file we want to disassemble, and we specify the output folder. So this is a small example. Small code is actually pretty easy to read. We have a method called isAuthenticated. The set at the end indicates that it's going to return a Boolean value. Locals 1 means there's one register which this method uses. So basically, Dalvik, that's the Java VM for Android, is register-based, unlike the normal Java VM. And well, you can read that code. It's not that hard to read. I mean, it's like I get object, so it gets some object from here. It's a Dropbox client, and if equals 0, like we know that from normal assembly code, so it's not really hard to read, and there's some jumping going around, so pretty easy to read. The reassembling is also really easy. You just change something in that code we just saw, and for example, we just return always 1 or true for the is authentication method, so we're always authenticated. And you just specify B for build, the output folder where we stored the APK tool output before, and the new name for the app. What you have to do as well is sign the the APK file, because Android will only accept files that are signed. Self-signed is fine, because the only reason why it has to be signed is actually because every update has to be signed with the same key again. So if you want to update your app, you have to sign it with the same key. So basically, you produce a new key. You say jar signer, please sign that APK file, and the last line already installs it on your mobile. So ADB install means if you connect your phone over the USB cable and you have USB debug on, it will install the app. So really easy. Okay, there are some other techniques for pen tester which are pretty helpful. There are a lot more, but just explain some of them. You can make heap dumps actually on Android. Of course, you have to be root, so you have to root your phone first, but that should be no problem at all. You can find out the process ID, and afterwards with kill -10, you can produce heap dumps. So you will find the heap dump in DataMisk, and you can grab for it. For example, here, what I did was, for those of you who know KeyPass, otherwise it's not that important, but I opened KeyPass database, I entered my master password, and I added a new password into the key store. And when you look at the heap dump afterwards, you still find the new password that I included. So basically, you can look which variables are still stored in the heap if you're reversing NAP. On Android 2.3 and above, you have to do it a little bit different, but well, doesn't matter. Okay, another thing is actually invoking activity. So an activity on Android is basically one screen. Like you have one screen, you have some buttons, and if you click one, it changes to another screen, right? And a lot of apps have like the first screen is your login screen, and if you don't type it in correctly, you won't get to the screen 2. Now the problem is a lot of developers don't check if on screen 2 again if he's already logged in. So basically you can just start an activity directly. So you can here you start the password activity directly, which is maybe the second screen, and you don't have to log in on the first screen. Unfortunately, this example doesn't work because KeyPass is correctly implemented. Okay, there are tons of other tools. Android Guard. I won't talk about all of them, and I haven't actually used all of them, but it's getting more and more every month. And when I started, there were actually not that many tools, and well, also the thing I explained with downloading the APK files. Today you have a Google Market API, so you would just basically use that library to download these APK files. But I was just trying to tell you how you can tackle these problems if you just want to. If you know there's something on the wire and you want to store it on your laptop. So I hope this is now the most interesting part, my experiences when decompiling and disassembling so many apps. As I said, 3,500 apps. I found about 2.3K email addresses, so if you want to spam around. Yeah, the developers really love swear words, they really love it. And you find a lot of Twitter, Facebook, Flickr, geocaching API keys. So I don't really get the point of API keys anymore, because it's like a key, so not everybody can, but somehow you can just extract them from everywhere. Okay, so let's talk about some low-hanging fruits I found. But first, let's do just a small hashing and encryption short best practice refresh. So if you want to hash and encrypt, you should use secure algorithms and implementations, random and long salts. And when you do hashing, you should use a separate salt for every hash. That's just best practice. You should use several hashing rounds. And when you do encryption, that's the most important part. If you do encryption, you should keep the key secret. I mean, there's no point in encrypting anything if you don't keep the key secret. So this guy here, it's not that bad, but he just used a static salt, right? And he was in the process of thinking about, yeah, now I have to like hash something else, and I don't want to use the same salt. But he was not like dynamically creating random salts. But what he did, he was like, oh, now I need a better one, so I write in this one even better, and the same salt again. So, but still static, so it would have been much better if he just produces one on the fly and then store it along with the hash. Yeah, now we're getting to the interesting part. This is an AES key, because here's a byte array, and then we see, we'll use it, oh, we produce a key. So basically, whatever encryption is going on here, we have the key for it, so we can decrypt it. And the funny thing about this key was actually, when I was looking at it, a byte is normally like from 0 to 255, right? But none of them is over 128. So the most significant bit of this key for every byte is 0. And I was wondering, why would anybody just, what was he thinking? And the problem is actually, I guess, that if you want to use integers like this to initialize a byte array, you have to use signed integers. You cannot use unsigned, so you cannot use 0 to 255, but you have to use minus 128 to 127. And so the developer was like just trying out and was like, okay, 128 doesn't work, so I'll just use numbers from 0 to 127. Actually, it was used to send passwords in HTTPS, so it was still protected by SSL, so it's not that bad. Yeah, there are more of these guys who do the same. Can anybody read the secret message? Olympic Soccer World Cup Hockey something. But still, secret key in the app, so simply use it, decrypt it. It was used to signalize the server that in-game goods were purchased. So this was actually a game, and now I'm the fish tank master because I have all the fishes in the fish tank game. So basically, yeah, really good at it now. Yeah, no comment on this one. And yeah, please don't correct me. What some of the apps try is obfuscate their code. As most of us know, obfuscating code doesn't really help most of the time. If you look at this code, it doesn't matter actually what is going on down here, but as we see, there's some secret key factory and some secret key anything. And we see that there's an A array, a B array, and one parameter to this constructor. So if we know all the inputs to an encryption routine, we know how to decrypt it as well, right? So I was wondering, okay, we have this byte array, but where is this coming from? Is it user supplied or key derivation function or whatever? So the question is, who calls this AH constructor? And of course, 4 grabs later, you'll find the answer. there's a class called c.f, because obfuscators always like shorten class names. So there's a class called c.f. It includes, let's say, a string. C.f calls a.bs, a.bs calls a.ah with the key, a.ah uses the key and all the local variables for encryption. We know all the input data for the encryption routine. It's symmetric crypto, so we can decrypt it, whatever it might be. Some other stuff I found was that one guy was writing an email parser. So he wrote the class test something.java. And he said, yeah, I'll have to test the class. So he just pasted in one of his emails. So I could read all his, or one of his emails. That's not that bad, but well, basically you should remove that Java file before sending it to the Google market. And the same guy thought, yeah, I'll also have to authenticate against the server. So he wrote in his email ID, his user ID, his passwords, his server name, and his domain name. So you have all the credentials you need to access the corporate server. Okay, that was just the low-hanging fruits. Like sometimes I don't even know what the encryption is used for, or I just don't care. But yeah, there are really a lot of keys in the code. And let's look at some apps I looked at more closely. The first one is a banking app. And I always wonder who really wants banking on the mobile. I think it's not the IT security guys most of the time. There are a lot of apps who, which do banking on the Android platform. And this one had no obfuscation at all. It could be easily be recompiled, so I just changed some code and recompiled it again and said, yes, send the credentials to my server, please. And the app simply shows the website. So the app is actually nothing else than a worse browser. So it's like the app opens, there's one window, it loads the normal ebanking.whatever.com website. And the problem with it is that it hides the URL. So whenever you told your users, yeah, you have to check if it's HTTPS or just HTTP, and it also hides the SSL certificate or the small lock you have normally for SSL connections. So you cannot tell your user anymore, yeah, you have to check if it's HTTPS or whatever, because you won't see anything. If he downloads the wrong app, which has exactly the same name as the real app, and it's just from another vendor, which has a similar name. You know, on the Google market, you can put everything. Yeah, how should he know he's not connecting to his bank? And another problem is that this app can only be used with mTAN. So you get a mobile TAN, so you get an SMS on your mobile with as a two-factor authentication, right? But the problem is two-factor authentication means there are two factors. So an attacker has to own two things or to know two things or whatever to really get through with his attack. But actually, if there's malware on the mobile, the user types in his password into the mobile, and he gets the SMS on the mobile, so malware can read everything. So basically, this two-factor authentication is a little bit useless because it's, well, no, that's not correct. It's not useless, but, well, it's not that good. Well, to be honest, there is actually another option. You don't have to use mTAN. You can also use a USB stick, but I'm not sure how you plug in your USB stick into your mobile, so I guess that won't work. So Dr. Evil will be very happy to write some malware for the Android. Okay, another app, which the first problem was that it has had a self-signed SSL certificate, which is bad on its own. So we did a man-in-the-middle attack, standard man-in-the-middle attack for SSL. And what we saw was something like, oh, that's not really the password we entered as a test. So basically, it looks like encrypted. So don't we need a key for that? And of course, you'll just find it in the app. So self-signed SSL certificate and key in the app is pretty fail. Now another topic. Um, some mobile device management vendors try to um, sell their customers like you can detect if a phone is rooted or not. And one of these vendors had this code in it. So the method is called device root, and it tries to execute su, the super user command. And if it works, it returns true, so the device is rooted. Otherwise, the device is not rooted. So I was thinking, yeah, well, that could be hard to like circumvent this because every app can call su if the phone is really rooted. But then I realized, well, when I did my routing, there was an app installed which is called superuser.apk. And this superuser.apk Android app does nothing else than before an app is granted superuser permission, it asks the user. So it was not necessary to circumvent this root detection. So basically, the app is ask you, oh, there's an app from your company which wants to get root permissions, and you just say remember and deny, and your company will never notice that your phone is rooted. So the feature of this device management solution is not going to work at all. Of course, another vendor is trying exactly the same. Like they're doing it a little bit different. They're checking if the system sbin.su file exists or not. And basically, I thought, yeah, let's alter this app and change something. So I disassembled it, and then I used the sed command. Well, basically, it just changes sbin.su to system sbin kevipslk. And I guess there is actually no file called with this name on an Android system in system sbin. So the detection will always fail. And I signed it again and uploaded it again, and well, it worked quite well. But what I was asking myself was that a good method to remove the root detection, because every time there's an update, I have to do this disassembling, changing, and reassembling again. And actually, we only want to fail that simple check. So to prevent the root detection, well, the upper stuff is not that important, but actually what I did was I looked into the path variable and just moved the su command from system sbin.su to system xbin. And it's inside the path, so all the apps will still find it, but as you remember, the app was checking for the entire path, so system sbin.su, and it won't find the su command there, but it will, well, all the other apps will just execute su normally and will find it. So that root detection was broken as well. So the lesson learned is a little bit, root stays root. I mean, the user is root on that phone, so he has the highest privilege of all. And now the company is installing some app which has normal Android privileges, and the unprivileged thing is trying to check and control root. Somehow it doesn't work. Like there's always a way around it because you have more permissions than this app. Well, and one day I realized there's actually a really special secret key. 445 apps use the same AES key. I was wondering, why would all these apps use the same AES key? And the winner is Google Ads. What they do actually is they encrypt the last known location of the user. So they get all the geolocation information from GPS, your Wi-Fi, and they encrypt it with the key we saw. And they send it via the UULE JSON parameter to the Google servers. And well, I notify Google, but seems they don't care. And well, actually, to be honest, I haven't seen the UULE parameter on my network yet. I still have to do that. But the thing is, just why is Google Ads using symmetric crypto? When they use asymmetric crypto, nobody on the network would be able to decrypt it because you only have like the public key, And the public key, for example, is only used for encryption, and nobody can decrypt it because you don't have the private key because it's only stored on the Google server. So I simply don't guess. It's not that of a big problem, but if they do encryption, if they implement it and use it, well, then they should use asymmetric crypto because it's just secure. Because this version right now doesn't help at all because everybody knows the key. So the countermeasures are basically developers should use more asymmetric crypto instead of symmetric crypto. So attackers on the network cannot decrypt the traffic. They should store more hashes and session tokens instead of passwords. A lot of apps are still storing passwords in in plain. And actually, the protection mechanism is like the Linux kernel. Android is just another Linux, and basically every app is one user, and one user cannot read the data from another user, and that's the protection mechanism. But yeah, as we all know, there are a lot of kernel exploits and stuff. So there are a lot of routing exploits around. Well, yeah, and good obfuscation is just security through obscurity, of course. You should pen test your apps, so I'll have a lot of work to do. And you should also know the limitations. Of course, root stays root. Here are some references, and thanks. You can follow me on Twitter or just visit my website. Are there any questions? Great. Hello, hello. I'm not sure if it's working.
It is working, yes.
Sorry.
In your point of view, with your experience, what is the best device, Android device, to make security researches?
The best device? Well, actually, it depends not that much on the device, unless you're like really going for the specific stuff. Like HTC is different from Samsung, and well, in the end, it's also important which Android version. That's actually more important, which Android version you're running, because for example, Android 4.0, which is not out yet, but it will have ASLR, and it will also have a keychain, so you don't have to store all these passwords in plain anymore. So it's more important which Android version you're using. But well, in the end, it doesn't matter. You just have to check that there is a root exploit for your Android version, so you can just poke around.
I have a question too.
Yep.
Why you could retrieve only 3,500 apps, even though you found 10,000?
Well, basically, I was a little bit lazy. My code was a little bit lazy. No, in the end, Google, the first like 50 or 100 apps were just like I got normal HTTP 200 responses. I guess because the APK files were small enough. So I just got, yeah, okay, here is the file, and I stored it, and then everything was good. So I automated it and just let it run. And after these 3 days, I realized that for big apps, it's returning HTTP 206 or something like that. So there's more content coming, and yeah, I just forgot that point. So. But basically, I just have to correct my code. Or these days, I would use the Google Market API library to just download the apps. Did it answer the question?
From your research, have you seen any applications that try to protect themselves? The question gives in the following direction. You mentioned that it's pretty easy once you're root to stay root.
Yeah.
If you have an application that communicates with a server, let's say, as all applications are signed, couldn't you as an application first check if it's signed? And if you communicate with a server, once again, check if it's still the original certificate or the original digital signature on the application.
Yeah, you mean by changing? Yeah, I know
so
what
if
you
you
mean.
recompile it and sign it with your own signature,
well,
it
the
would
problem
change.
the problem is actually that it's like the app is unpacking itself. So the APK file is already installed on the Android device. So it's somehow unpacking. And first of all, I don't think that the Android app has access to the original APK file. Even if it had, it wouldn't know if the unpacked version is still correct. So I guess you could implement some things, but the problem is still the same. When you root, you have more permissions, or yeah, all privileged, and can also always.
Okay, so
handle stuff.
nothing in this direction you have seen with all the applications.
Not
you've
that far.
researched.
Well, I'll had some crashes with the decompiler, and I'm not sure if the apps are trying like anti-reversing techniques, but I'm not sure. I don't think so. Any more questions? Nobody? Okay, thanks.